Hey, 8th grade, this is Miss Harkness. This is a PA Coach worksheet on comparing functions. This is something that I know our class has struggled with, and I just wanted to quickly go over just what's kind of going on this worksheet. So here at the beginning, it's just some definitions. Goes over rate of change, slope, what the y-intercept is, what slope-intercept form is. So if you need a review on that, go ahead and pause and read it over. Here on question 1, or example 1, it says the table and the equation represent linear functions. Which function has a greater rate? So you can see that we have two different functions here. Function A is represented by a table, and function B is represented by an equation. So let's start with function B, since we can already see the rate here in the rate spot is -3, right? Because y equals mx plus b. The m is always your rate. So then let's kick over here to the function table and get our rate. If you remember, you can calculate rate as slope, so y2 minus y1 over x2 minus x1. I'm just going to go with the first two ordered pairs. So my y2 would be 17, my y1 would be 21. Right, I'm getting those from right here on the table. My x2 would be 4. My x1 would be 2. 17 minus 21 is -4. 4 minus 2 is 2. So that reduces down to be -2. So my table has a rate of -2, which when you think in terms of negative numbers, -2 is actually greater than -3. So if we kick over here to the next page, you'll see that the correct answer right here, function A, which was my table, because function A has a slope of -2. Function B, my equation, has a slope of -3. Let's look at example 2. It says Marcus graphed the function shown below. Anna wrote the function given by the equation y equals 4x minus 2. Now this question says, which function has the greater y-intercept? Let's start with Anna. Anna equals -2, and I have that right here from her equation. Then when we look for Marcus, Marcus's is right here on the graph. Marcus is down at -4. So as you can read here in the answer, Anna's function has a greater y-intercept, because when we think about value, -2 is greater than -4, so Anna has a greater y-intercept. Let's move on to example 3. Example 3 says, Sean and May leave an amusement park at the same time. Both drive home at a constant speed. The table shows Sean's trip, and the graph shows May's trip. Who got home first? So we're comparing x-intercepts here, meaning x is usually your time, right? And y is your distance. So when y is 0, what is your x, right? When you have no distance left, how long has that taken you? So we're going to start with Sean. For Sean, when y is 0, right, no distance left, x is 5. So 0, oops, I wrote that wrong. This is Sean. So looks like at 5 hours in, he has 0 miles left to go. Then let's look over here at May's graph. May, when y is 0, oops, I did it again. When y is 0, x is 4, and that's right there on the graph. So it looks like May, when she has 0 miles left to go, right, her distance, she's only traveled 4 hours, so her time being 4. Now here for the strategy, the question kind of walks you through it. It says, find the number of hours it took Sean to get home, find the number of hours it took May to get home, compare the two times. So that's what this question's saying. Naturally, if it only takes you 4 hours to get home, that's less than 5. So May got home first. Let's look at this last example. Example 4 says, Carlos and Kate are reading the same book for class. Carlos read 30 pages so far and plans to read 15 pages each day to finish the book. Kate's plan for reading can be represented by the equation y equals 18x plus 20, where x is the number of days and y is the total number of pages read so far. Who plans to read the remaining pages faster? That's important. The question does not ask who will finish first. The question asks who will read the remaining pages faster. That question is asking me who's reading faster. Now, it's easier to see in Kate's because we already have her equation, but let's start with Carlos. Step 1 says, find Carlos' reading speed. Write his rate as a unit rate. So he reads 15 pages a day, so that's his rate. And the question explicitly said that, so that's helpful. Then it says, find Kate's reading speed. Now hers, you have to know that 18 is her rate because it's in the rate spot. So Kate's reading 18 pages a day. Dun, dun, dun. My final answer, Kate plans to read the remaining pages faster. If I did need to write an equation for Carlos, Carlos would equal 15 pages a day, so 15x, plus 30, right? His initial value is 30. He's already 30 pages in. And then we had, for Kate, her initial value was 20. She was 20 pages in. So Kate's reading faster, starting at 20 pages. Carlos is reading slower, but starting at 30 pages. Here we only need to know who reads faster. But we could solve the system of equations to find out when they're on the same page. And if we knew how long the book was, which we don't know, but if we knew how long the book was, we could find out who would finish first. This coached example is something you could try on your own. So go ahead and pause the video for a second and see if you can figure out which company charges more per minute, and then resume because all the answers will be here. All right, here we go. We know that the unit rate for the named company, so up here in the scenario, is 0.2. Then I pulled 2 points from the graph to find the rate for plan B, which I got was 25 cents a minute. Well, I got 5 over 20, but I converted that to a decimal. Since 25 cents a minute is greater than 20 cents a minute, plan B charges more per minute. These next couple slides are just some example problems that you could try on your own. One's a little tricky because it's asking about x-intercepts. So you would have to put into each of these equations y equals 0, because that's how you get your x-intercept, and then solve for x to see which one is not greater than Raul. For 2, you'd have to compare the rates. For 3, you're going to have to write Liz's function in order to be able to compare it to Evan's. It says which statement is true. Here on 4 and 5, you will solve which statement is true about Lee and Ella's walk home. 5 says which function represents Lee's walk home. You'd need to find your slope and then your intercept. 6 says which function has the same y-intercept as Jen. So there it says Jen has a -5. So it looks like you're going to have to do some rearranging on 6 to find which one works. 7 says which table represents a linear function that does not have the same rate of change as Jen. So that 0.1 rate of change. So which one, A, B, C, and D, does not have 0.1 as a rate of change? So you'd have to check all of them. Here on 8 and 9, 8 says which function represents the amount Leo will donate. 9 says which statement is true. 10 says which statement is true. And then 11 says which statement is false. Lastly, here's some open-ended questions you could also try if you're wanting some extra practice. All right, hope this video helps. Good luck.